I have a two-zone, two-stage heat and cool system recently installed controlled by a Honeywell HC322 zone control panel. Each system, heat and cool, worked perfectly for a year until I had an HVAC technician tune up my air conditioner. Since that time, the cool 2 LED flashes, oftentimes, and the blower doesn't run in high speed when this occurs. I have since had them back out and the same technician determined my system was undercharged. He added Freon and claimed the system healthy, after a token search for leaks. Since then, the cool 2 lockout occurs, most often when it's very hot outside, although not always.
Did you double-check the thermostat settings? And what about the filters?
Filters are new. Thermostat settings haven't changed in a year. My question is the DATS reports no lower than 43 degrees, yet the minimum setting is 40 degrees. It seems to me the cool 2 lockout should not occur. Is there any other reason for a cool 2 lockout besides being below the minimum?
Do you plan on doing the work yourself?
I have a maintenance contract with the HVAC company. They need to fix.
Anything else we should know to help you best?
Is 43 degrees DATS temp normal, or is this indicative of low charge? Also, am I doing any harm to my system by running this way?
Greetings. After 56 years in this business, spotting fraud and incompetence, often in combination, has become easy for me. I hardly know where to start. It is quite likely that the technician sabotaged your system control wiring in order to create the cool 2 LED flashes error and blower malfunction, knowing you would have to call them back to handle that problem. Then when he returned, he added a few ounces of refrigerant to the system, overcharging it with refrigerant, and causing the outside unit high pressure cutout switch on hot days. You need to deal with a different HVAC company. That one has way too many red flags popping up. Regarding the DATS, discharge air temperature sensor, reading 43F, that is about 12 degrees Fahrenheit too cold if the home is at 72F, I suspect the sensor connection has been tampered with, or is disconnected, or bad if I did not suspect sabotage. 55F DATS is the norm for discharge air temperature when the house is at 72F. Click here please. DATS should run between 15 and 20F cooler than the room air in most normal operating conditions. A disconnected DATS would also cause the blower to run at incorrect speeds under many conditions. If you can tell me which direction you are from the center of the nearest larger town or city, I will see if I can find a well-rated service outfit for you. Important note about rating my work: I am a retired mechanical engineer and HVAC/electrical/refrigeration and boiler contractor. With 56 years in this business. The last 20 of those years consulting for major firms nationally. All I ask is please select the rating link at the top of your page. That is the only way I am credited through the site. Rating does not affect your charges nor ability to refund if not satisfied. If you need to be coached through a full diagnosis/repair, and wiring etc. for up to 2 days, and wish to be trained to use test instruments. That goes well beyond just a simple answer, of course, and goes beyond what most other experts here offer. Rate my simple answer so far positively. And I will deliver that training and coaching to you all on the same dime, so to speak. Attach a close-up photo of the wiring diagram glued to the inside of the blower access door, and I will mark it up with troubleshooting instructions, then follow up with step-by-step training and coaching until you have a solution. Photo must be exceedingly well focused. Use the Add Files link next to your Send button to get the photo to me. Phone call offers: if you wish to accept the company's $25 phone call offer, if indeed they send you one, this will go a lot faster. but it is 100% optional. Or we can continue here in this dialog box at no additional charge.
Thank you, Bill. Regarding the technician, I doubt he was that clever. He was a young fellow, I don't judge him for that, but he was inexperienced, that had to read the inside of the zone control for clues as to the meaning of the cool too. I suspect inexperience or incompetence. My heartburn is the 43-degree evaporator reading. The DATS is reading accurately, it's truly that cold, and the 40-degree set point on the zone control. Why would the zone control lock out 3 degrees higher than set point? Do I have a bad zone control, and is the low evaporator temp indicative of under or overcharge? Thanks.
Hello again. You can buy a dial-type thermometer with a 6-inch stainless steel probe on the back from any auto parts store for $7 or so. Insert that into one of the supply air registers, and you can measure the DAT temperature. I suspect it will be 15 to 20 F cooler than the room air, 55 F at the coldest. Click here for the optional DAT setting instructions. Someone set it 40 F by mistake, or to bypass it entirely if they indeed knew what they were doing, and wanted to bypass its low temperature function. I suspect an error. Set it to 53 F for now. Let me know how that goes. Discharge air temperature and evaporator temperature are only related. The evaporator will run 18 to 20 F colder than the discharge air temperature in cooling mode. Regarding overcharged system, let the house cool to 72 F, then set the thermostat at 65 F for this test. Wait 5 minutes, then look at the largest copper tube attached to the outside unit. It should be sweating, and running 45 to 48 F. Then notice if the big black heavy looking compressor inside the condensing unit has any sweat on it near where that tube connects. The degree of sweat is the degree of overcharge. I am parking the HC322 manual here in case we need it later.
Thanks again, Phil. I have an infrared temperature gun and have verified the DATS temperature is correct. The technician also read and verified the reading with a probe and a fluke meter. I've noticed a lot of condensation on the ductwork exit of the evaporator. It is very cold, so I believe the 43-degree reading in others. The DATS is mounted directly above the evaporator. The house is a constant 72 degrees, so the 43-degree evaporator temp must be out of the normal range, for whatever reason. I have the same manual for the HC322. I was hoping for an answer as to why the cool 2 lockout occurs 3 degrees higher than set point. It seems like I should never be in lockout, and if so, with a higher blower speed, the evaporator delivery temperature would be more normal, in the 55-degree range, which it is when the blower finally is commanded to high speed. The DATS model number is 1548, if that helps. Looking at the DATS datasheet you provided, it looks like I went below 40 degrees and then it stays in lockout until the temperature rises above 50 degrees, or the thermostat ceases calling for cool on both zones and the DATS has time to heat up. Do you concur? I don't think there's anything wrong with my zone control, it's simply getting too cold. So, if that's the case, and I believe the DATS reading, which I do, what can cause the evaporator temperature to be excessively cold? Sorry for asking dumb questions, but I don't know and I think we're getting somewhere. Also, maybe a key point. After he added Freon on the second call, the evaporator temperature was, as far as I can tell, always in the range of 55-57 degrees, normal, right? A time later, I'd say maybe 2 to 3 weeks later, the evaporator temperatures crept down to the low values I have now, 43 to 45 degree range. Is this indicative of a leak? Perhaps caused by the tech. Maybe this is the problem all along.
Hello again, you are confused on a few points. Sorting that out will be a project, The college course is 20 units a semester. For 4 semesters, about half the students pass the course, the rest fail to grasp the concepts involved. The easiest way, but for sure not the best way, would be to take my word for a few of the most obvious items. Then if you do that, a lot of the confusion will unravel for you. First, the evaporator coil holds the refrigerant as it is evaporating. It is always the absolute coldest part of the system. Air passing though this evaporator in an AC system is always warmer, must be, per force of the laws of physics, warmer than the evaporator. Design practice is 20°F warmer air coming off of the evaporator coil than the evaporator temperature. That is because heat flows from the hot to the cold, and in order for the AC system to cool the air must be warmer than the evaporator, which absorbs that heat from the air. Summary: the discharge air temperature is always warmer than the evaporator by 20°F plus or minus depending on the volume of air. So that your 55 to 57 air temperature is perfect for the supply air, DAT. But cannot be the temperature of the evaporator coil itself. Key point: get it down pat, that will help you a lot. And 43°F is not too bad for an evaporator coil temperature, although I like to run them a little cooler than that. Notice the coil in this case at 43°F is 14°F colder than the supply air. If your suction line at the compressor is sweating, as it should be, and the compressor itself is sweating at any location, then indeed the system is overcharged with refrigerant. Second point, key point, is to understand that infrared thermometers are not to be used to measure air temperature. Use the dial type I mentioned earlier for $7 at any auto parts store. If you point your IR thermometer at any flat surface, and at a 90-degree angle to that surface, it will read the temperature of the surface to a somewhat reasonable accuracy. I do not use IR thermometers. In this business, use the mercury bulb or dial thermometer. Third, no thermometer is 100% accurate. There has never been one that accurate. In this business, plus or 1 degree Fahrenheit is about as close as we can get. Plus or minus 2 degrees is common. If you understood my point about the evaporator coil being 20°F colder than the supply air, this will become apparent to you. My guess is that you are measuring the 3/4 of an inch copper tube to get what you are calling the evaporator coil temperatures. And you are measuring the temperature of the cold air supply grill that puts air into the room to get your 55-57°F temperature. That would be the true DAT temperature. If the DAT sensor on your system is defective, or not mounted in the discharge airstream, it will give false readings. Assuming that false readings are accurate readings will generate a lot of confusion, of course, and that might be going on here. You can use the chart published in the link I posted regarding the DATs to verify accuracy, known temperature as compared to the ohm reading across the DATs.
Okay, well, I accept your good-natured ribbing. I wouldn't have lasted 39 years in the steel industry without a thick skin. I can say without hesitation that there is nothing wrong with my readings or the DATs. A spot check of the resistance of the TC at 58 to 59 degrees indicated 16.47 K ohms. The table shows 16.32 K, 58, or 15.89 K, 59. Additionally, as I stated, the technician also verified the reading with an independent probe and his fluke meter. The DATS is reading the air temperature of the evaporator output. It is mounted in the ductwork about a foot above the evaporator box. All of the readings I have stated are air temperatures. I do not have access to the evaporator box, and the suction line at the evaporator is completely insulated, so I have no way to measure that. In short, I am not relaying evaporator coil temps, just air temps. Since the DATS has been in the same location since startup, 13 months ago, and I've had zero issues with the AC, I'd have to say it's mounted correctly. So, DATS mounted correctly, reading correctly and reading air temperature correctly. This doesn't explain why the air temp is so low. Do you have access to the Honeywell HC322 Operations Manual, or other better detailed manual? The installation manual does not give much information as to the settings and options. Does this sound like I have a Freon leak? Immediately after charge, DATs in 55 to 57 range, after 2 to 3 weeks, DATs in 42 to 44 range, and stage 2 lockout.
Thanks, maybe that you are using the IR thermometer. It only measures the temperature of objects, and the cooling coil or any surface on it in the case will always be colder than the air temperature. No way can the IR thermometer measure air temperature. The issues here revolve around that aspect. Your 55-57F reading earlier is the supply air grill temperature. Your IR thermometer would be reading the metal of the grill, which will be the same as the supply air temperature because the grill is not refrigerated as is the evaporator coil. 55F on a 72F room proves conclusively that the system has enough refrigerant in it. Regarding a refrigerant leak, cut a slot in the black foam insulation on the 3/4 of an inch suction line at the outside unit, then follow it inside that unit to the compressor itself. If it's sweating, you are not low on refrigerant. If the compressor is sweating on any spot, there is too much refrigerant in the system. The 42-44F reading is something we get with IR thermometers, no telling what is reading. If it is in the supply air, you will have to confirm it with one of those dial-type thermometers I mentioned. This issue would be a bit like measuring a hot steel extrusion, solid steel, at 3500 F. And the crucible of molten steel at 2800 F. It's not possible that the molten is cooler than the extruded steel. So that we know for sure, there is some sort of measurement error. Let me know if that example makes any sense on your end or not.
Okay, your example makes sense. I have several of the thermometers you mentioned. We'll check tonight. In my experience, though, TCs don't just change their calibration. The value of resistance I measured was almost right on the table value. And again, the tech used another probe to verify the DATS reading.
You are correct, thermostats do not generally change their calibration. However, that 40F setting is not calibration issue at all, it is a setting. Someone set it at 40F. It is not reading temperature, it is reading its setting. You can prove that, if it is actually the case here, by locating the sensor and warming it up, it should still read its setting temperature of 40F. Warm the DATS sensor up by holding it in your hand. If it changes temperature on the display, it's reading temperature. If it does not change temperature on the display, it's a setting. You mentioned earlier that it used to read 56F, I believe. If it's a setting, someone could easily have changed it. We can get into calibration issues later if needed. Summary: the printed circuit board that receives the DATS ohm reading can go bad, not a calibration issue, but a defect in the printed circuit board issue. You can test the printed circuit board DATS circuit by inputting 10,000 and 20,000 ohms, just by those two resistors lightest duty you can find. The display should read 50F with the 20,000 ohm resistor attached and 77F with the 10,000 ohm resistor attached. Click here please. If you do not get those results, then the DATS circuit inside the printed circuit board is bad. Let me know how that goes.
Okay, the DATS readout on the HC322 is definitely the actual temperature. It changes all the time. Not a set point. In the meantime, I borrowed a Fluke 87 volts multimeter with a K-type thermocouple. The current DATS readout is about 2 to 3 degrees lower than the Fluke. I may not have the probe exactly in the air stream as the DATS is, so that might account for the error. Cool 2 LED flashing with a DATS temp of 42 to 43 degrees. I can substitute the 10K and 20K resistors, but I think that'll be fine. I'll let you know. Would still like to get a better manual on the DZ322. I think there's a setting in the advanced config called multi-stage DATS inhibit that would help, change from enabled to disabled. This should inhibit the panel from downstaging multi-stage equipment when near the DATS high or low limit, but I shouldn't have to do this, it was working fine before. After further review, the DATS sensor is right on the money, it agrees exactly with the fluke. There is no error between the two readings. Air on, air off, exactly the same.
Thanks, like valid measurements. My issue with the condition is extreme. There is no way you could measure 55 to 57F on the diffuser outlets, that is right on the money correct, and 40-43F at the air coming off of the coil. It is possible but not at all likely that the DATS sensor is located in a cold air pocket of still air around the cooling coil, a real long shot, quite unlikely, but that would explain this discrepancy. Can you use the fluke with its temperature sensor poked under the black insulation and about 2 inches parallel with the suction line and tell me what that temperature reads, at the same time you give me a temperature read on the DATS? And at the same instant, tell me if there is any part of the compressor itself sweating. That test will tell us a lot. Meantime, let's try it with the DATS unplugged from the zone controller and see what changes in behavior we get. Regard your desire for a manual on the DZ322. Did you mean HC322? Some of the instructions for the DATS refer to older and different versions of the HC322. 1 with dip switch settings relative to the DATS. I will spend some time on that. We are having lightning storms and heavy rain where I am, and the power is going out once in a while. Sometimes it stays out for a few hours. I should be able to respond suitably, however, but there could be some delays. If there are any dip switch or jumper settings on your HC322, please take a photo of the unit with the door open showing all the wire connections and the dip switches. I will appreciate it. Use the Add Files link next to your Send button for that. Photo must be up close and exceedingly well focused.
Yeah, it's C322. Sorry, my bad. No dip switch settings. I think maybe I misled you with the 55 to 57 degree readings. This value is on the DATS also. All values I stated previously were at the DATS. What I meant was that immediately after the tech added Freon, the DATS reading was in the 55 to 57 degree range. Now, as before, it's very low, 42 to 44 degrees, and cool 2 lockout. It's kind of slowly gotten colder to where it is now. Good luck with your storms. I'll have to get the readings tomorrow after work. Thanks. HC322.
Hello again. When the blower runs at high speed, it is designed to deliver 55F air to the supply air duct and out to the rooms. When the blower runs at a lower speed, it will deliver colder air such as 42F air. That is what we are seeing. There are dip switch settings on the printed circuit board that sends speed control signals to the variable speed blower. The tech probably changed those settings, or a jumper position on some boards causing the problem. Send me a close-up, exceedingly well-focused photo of the wiring diagram glued to the inside of the blower access door, and the brand name and model number of the furnace/air handler, on a tag in the same compartment as the gas valve. I will see if I can locate the manual for that unit. We can go from there. The blower speed control board is inside the furnace/air handler, not in the zone control panel.
Greetings, Phil. Sorry for the downtime, stuck at work. Adding pick files showing the schematics and airflow selection chart. I was with the tech when he had the blower compartment open. He didn't change any setting the first time, tried to the second time, and I wouldn't let him. I am also including the furnace installation guide and manual that explains the dip switch settings. In regards airflow settings, dip switches 1, 5, 6 and 8 are on, 2, 3, 4 and 7 are off. The way I read this is normal cooling airflow for a 3-ton condensing unit, which I have, enhanced mode fan off settings and medium-low heating airflow. The furnace is an American Standard Model A2B080A9V3 No smoking guns that I can see. I hope this helps.
Thanks. Possible that the Technic get the dip switch settings on the motor speed control board after you left. Given the history so far, make a sketch of where they are now and try a few different settings, then return the settings to where they were before you did the test. I need the model number from the blower motor in order to specify the correct ICM motor tester adapters in the event that changing the dip switch settings fails. Tester.
I was with the tech the whole time, especially the first go-round. He didn't have time, or knowledge, of setting. Just a quick look-see. I will have to test and get back to you tomorrow. Busy at work today. Thanks. Maybe a preemptive question: if there was a Freon leak, presumably in the area the tech had access to and nowhere else, basically assuming he caused a leak, would there be evidence of oil residue? I had a leak on my old system, granted it was bad, but there was oil all over. This was an old R22 unit. I ask this because I see zero evidence of oil residue. Anywhere. Maybe supporting the theory that he randomly added Freon to get $200 from me. Which I am fighting.
Oil around the service valves is normal, as disconnecting the hoses results in a small release of refrigerant and oil. You can use liquid refrigerant leak detector on those areas to be sure all the fittings are tight. Auto parts stores carry it. Oil elsewhere in the system proves a leak. If it has some semi-dry dust on it, then it's a very tiny leak. If it's wet with oil or dripping, then it's a big leak.
I see no evidence of oil anywhere. Blower motor is not very accessible. There is a list of part numbers on the blower housing. Motor part number looks like D344734P21. Not sure if that'll be it. Adjusted cooling fan speed to high value, dip SW3 on. Still collecting data. How about the operations manual for the HC322? Any luck?
The only manual I can find on the HC322 is the one I posted earlier. Any fan speed related problems are most likely with the motor speed control, not the HC322 zone control. http://www.shortyschwarz.com. Call them on the phone, give them the brand and model number of the furnace/air handler. Tell them it's ICM motor and controller and get a price on the electronic motor tester they sell for that particular motor, probably a Zebra. When you get that in, follow the directions that come with it on how to use the device to diagnose an ICM motor.
I'm a little confused here. How did we get onto the ICM motor is bad? Or controller? One recent data point since changing dip setting, Cool 1 DATS reading 49.3 degrees, was 42 to 44 degrees at lower speed. 1 point doesn't make a trend, we'll see. Tomorrow will be in the mid-80s.
That is what the Zebra, or other brand, diagnosis instrument is designed to do. Diagnose both the motor and printed circuit board that controls it.
Greetings, Phil. It would appear that adjusting the cooling airflow cured the problem. The current DATS in Cool 1 is between 47.7 and 49.7 degrees. The fan is noticeably louder. Cool 2 kicks in without error and the DATS reading is around 55 degrees. The HVAC company has responded to my letter and will be refunding me the money I spent. They are also sending out an experienced tech. One final perhaps dumb question: if there was a Freon leak, how would it manifest itself in terms of air delivered from the evaporator? Would the evaporator get colder and colder until it finally froze over? I think that's how I've seen it at work and elsewhere. If true, that always seemed counterintuitive to me, but hey, whatever works.
Freon charge has no effect on air delivered to the evaporator unless it got so cold on just the Freon inlet to the evaporator and ice that part of the evaporator. Then the ice works its way across the entire evaporator. I have eliminated that possibility with my tests, however. The Cool 1 should slow down the compressor as well as the fan, so that the supply air does not drop below 50 F. Any cooler in the ductwork and air outlets can sweat, causing them to rust.
I don't mean the air temperature delivered to the evaporator. I mean the evaporator temperature itself. Will a low charge cause the evaporator to freeze up?
Yes, if a system is slightly undercharged, the evaporator will be below the freezing point of water and ice will form on the evaporator. Evenly across the entire face of the evaporator. If the system is grossly undercharged, the evaporator where the liquid refrigerant flashes to gas will run below freezing and ice only that spot at first. There are many variables on that situation, but all of them are along those lines. A totally iced coil will block about 90% of the airflow, and that air temperature will be very low, depending on the room temperature at the time. A partially iced coil, on the other hand, will only block part of the airflow, and the rest of the air that passes, though the coil will not be cooled significantly, so that the airflow reduction will be noticeable but not extreme. And that air temperature off of the coil will be closer to room temperature. There are many variables on the as well, but all along the same lines: business and billing issues. There are other potential issues. If the tech who sped up your fan and solved the problem did only that, there would be no profit on parts for his employer. So it is not uncommon that he also finds some additional issue, such as the system was low on refrigerant, causing the coil to ice. That could be true or not true. That said, such a company that is fabricating the claim will often state they had to add more refrigerant than the system will even hold, and then charge 2 or 3x the going price for it if the company says they added only a few ounces to a pound of refrigerant and charges in the range of $36 a pound for it. Their claim in that case would most likely be legitimate.
That is great information. Thanks.
If you have a home improvement or appliance question and want to chat with an expert now, visit justanswer.com/YTHI.